But if you lean and make contact with the wall, by outstretching your hand, you will not fall. Have you ever wondered why? That's because when you push the wall pushes back on you. So you are supported. Newton realized force is an interaction between two things. If a hammer exerts force on the nail, there is also force that is exerted on the hammer. In this case, the hammer does that. So in this interaction between the hammer and the nail, there are two pairs of forces, one acting on the nail and the other on the hammer. Newton explained this by his third law, which states that whenever one object exerts a force on a second object, the second object exerts an equal but opposite force on the first object. One force is called the action force and the other is reaction force. They are equal in strength but not in direction. And how Newton also said, to every action there is always an equal opposing reaction. In every interaction, the forces occurs in pairs. For example, if we walk on the floor, we interact on it. We push against the floor, so the floor at the same time pushes against us. Or for example, the tires of a car interact with the road. The tires push against the road, and the road at the same time pushes back on the tires. You push them backwards so the tires move forward, so this produces the car's motion. When the friction is minimal, we may not be able to exert an action force, as for example walking on ice. So without an action force, there is no reaction force. Thus, there is no forward motion.
Everybody's out to get you.
Another example of an action would be when a rocket pushes gas, and the reaction would be gas pushing the rocket.
'Cause if you ever feel neglected, if you think that all is lost, I'll be counting up my demons, yeah, hoping everything's not lost.
When objects are pulled by each other, the masses don't matter on the subject of how action and reaction are pulled. If a boulder is thrown on Earth, then the force is equal as if Earth is thrown to the boulder. It is true that mass is also a factor, because when the boulder falls on Earth, we don't see the shake, because it's a very tiny fraction. Even though it's a tiny fraction, Earth still moves. Another, less exaggerated example is a cannon. When a cannon fires the ball, the same force is applied to both objects. Because of the smaller mass of the ball flies away and the cannon only moves a little because of the larger mass. In contrast to those objects, according to Newton's third law, we can lift massive objects using the molecular particles as a reaction force. The way on how a helicopter uses its blades to push against the air particles can explain this phenomenon on flight. This particular complex event is called lift, where the object goes up and moves accordingly to where intended. That tricks many people is the horse cart problem, where when it is observed, we come to think that the cart is impossible to move. the force put to the cart from the horse makes an equal push-pull factor where force is cancelled. So how is the cart moving? The simple solution is that the horse puts force on the ground, receiving an equal force back to the cart, causing acceleration. This process then doesn't need to be put against it another method to cancel out the friction that the cart's wheels put from the ground. When looking back at this, we see that the cart and the horse are internal forces that act upon each other, while when outside force is put from the ground, the cart starts to accelerate.
You wrong.
In the beginning, I talked about how a wall pushes back on you when you push against it. If you punch the wall, you will hurt your hand. Even if that sounds weird, you can say that the wall hit your hand. And it really did hurt your hand as hard as you hit the wall. You cannot hit the wall any harder than it can hit you back. So for every interaction between things, there is always a pair of oppositely directed forces that are equal in strength. If you touch the world gently, the world will touch you gently as well. The way you touch others is the way others touch you. You cannot touch without being touched.
Alone.
Outstretching your hand, you will not fall. Cada says you can fall. Have you ever force on a second object? The second object.
Go.
Example when an orange is in a system.